Okie dokie. I think we can get going. So, Vladimir, take it away, please.
Okay, colleagues, should I start?
Yep, good to go.
Cool. Okay, colleagues, I just want to raise one question to the audience. Am I the only one in the room who occasionally delete my data from SQL table? So, unfortunately, I couldn't see your arms, but I hope you just, yeah. Thank you.
Definitely one arm here. I've seen
I-
1, 2, 3. The Slack channel's clipping up. People are
Cool.
doing it. Andrew, I've been there when Andrew's deleted it as well. So yeah, there's plenty of people here.
Yeah, I guess you're smiling, guys, and I know what to feel. So this just happened. Your data has gone, boom, and that's it. So when that first time happened to me, I was about to panic, to be honest. So what shall I do? Just to run wizard to reload data from another instance, or go to the DB admin and ask him to restore it back from the backup, or maybe pay for third-party tool just to make it for me? Well, from that time, I got some experience and learned some internals. So now, what if I tell you that it is possible to resurrect your data by a simple SQL script? Yeah, my name is Vladimir, and I'm here today to show you some internals about this. So let's go. Yeah, that's actually happened. Yeah. So what should we do? Let's review the slides and got some, I would say, basic knowledge. Yeah, because this presentation I also used for some general data conferences, not so much back into SQL internals. So let's review some, I would name it basic stuff, but I hope still you could follow. Some people could learn something from this. So yeah, why do we need actually transaction log? Yeah, it's the first question we have here. What is it actually in the database? We have such, let's say, we have data log file. Yeah, so it's actually records all the modifications in the sequence in a chronological order and captures every changes made on the database. Yeah, this is crucial part here. So it's essential for the recovery. So it enables point-in-time restoration. So, and it's really critical, yeah, for business. And it ensures our ACID acronym, which means atomicity, consistency, isolation, and durability. Yeah. And this is on the bottom of the slide, you can see some very primitive basic example of what would happen when you delete your row from the table. Yeah. So it happens in a transaction. So there is a timestamp. Allocation unit will come to this a bit later. And your operations, you open your transaction, you delete the row, and you commit it. And we have LSM. So next question, what is actually LSM? Naming by log sequence number, yeah? And this is our unique identifier for the log record. And yeah, it enables precise tracking of database changes. Actually, this is your unique ID of the record in the transaction log. We'll also come to this in details later, but let's just keep it for now. And what is also interesting about transaction log? Everything is happening in transaction, yeah, context. So each modification is executed in the context of transaction, meaning it's you open it explicitly with begin tran, or it's open for you implicitly. And this is maybe more interesting case for us when we actually forgot to open the transaction explicitly, so there is no way to control the rollback. Yeah, so your transaction is committed automatically when you forgot to open the transaction. Yeah, so what is also interesting about transaction log in general, it stores data in binary values, mostly, yeah, the row log record. Well, it has its benefits. It takes less space. It's unified and a precise format. And we'll also talk a bit about this later, but yeah, let's keep it so far. So let's go further. Another basic stuff, but let's explore it. Yeah. How to actually store data? We store it in data page, hopefully not a secret for the conference called 8 kilobyte. Yeah. And so we have the page header that contains metadata about your row, not just row, but the page. And there are many stored there in the row header. Then we have our data rows stored in the binary values. Yeah, so we can see on the right hand side these data rows, and then we have row offsets, indicates logical order of the data rows on the page. So if we want to sort them, we just sort these offsets, and it's easily to follow them. But your data rows to stay in the middle, yeah, physically. So next question for the audience, maybe let's review fixed and variable length data types. What's actually the difference between char and varchar? That's the question we usually ask some candidates on the interview. So why not? What's the benefit? What's the benefit of use this or that? Yeah. Well, fixed length. Char is fixed length, yeah, and varchar is var length. So storage behavior always takes up the full defined length of char 10 and always uses your 10 bytes. So if you allocate char 10, it always takes 10 bytes. Well, for varchar, it uses only the needed space and plus 2 bytes for the length storage. And we'll also go to this a bit later. So then the question is, why not to use always the varchar? Yeah, because of this additional bytes. So and performance-wise, of course, for char as a fixed length character, it's faster for fixed size because it doesn't require length calculation. You know it in advance. Yeah, and for variable length, saving space but slightly increasing processing time, meaning you need to know exactly what is the length of your varchar column. And usage scenario, well, yeah, some country codes, currencies, whatever we know in advance takes precisely this length. This is your char value, and varchar, well, names, descriptions, comments, whatever. Okay, so then we go to the next one. What is inside data row? Yeah, so we have some technical bits, A and B, to store some bitmaps of the system pages, but let's do not touch them today. Let's go into this third byte and this green block, which stores the fixed length part of the row. Yeah, it starts with fixed data length. 2 bytes stores your fixed data length. Then you have actually your data. And we know how much it takes in advance because we have fixed data length. Yeah, here. Then after that, we have 2 bytes to store number of their columns. And then null bitmap. It could be, depends on the number of nulls you have in your columns. Yeah. So this is fixed length. Then we go to this blue block, which is variable length. So we have number of variable columns in 2 bytes. And then we have column offset array storing each of 2 bytes, storing the offsets of your variable length columns. So we should go there first, read them, and then we go and we can easily withdraw it from variable length. So, and then we actually have the data. Yeah. So That's what we're interested in. So there could be additional storage for temporary for this optimized deletion levels, but let's do not do this today. So that's what we should concentrate on today. And here is an example. We create a table, some simple example. Let's name it fixed. And we have some fixed length columns and data types. And insert just one row for this demo. And I will show you the code and then delete it. So I guess it's the time to show this demo. So, okay, yeah, let me also describe the process. So what we should do. So as you may know, we have this well-known FNDB log function, yeah, which is officially not documented, but there is a way to explore it. And I guess, colleagues, you also try to investigate yourself what is inside it. We just filter by the table name, and here we have our allocation. Well, this is never code, but this is just you to follow. We filter by the table name, and find our delete operations. So we have our transaction, we have our row log content 0. This is the value with the actually your data, which was deleted. Then we need some additional functions to actually interpret these hexadecimal binary values and get them back to the human understandable format. Yeah, and the last piece of the puzzle is just to check the data types you have and convert them back to the proper data type. So that's basically the algorithm of doing this. Yeah, and this is the store procedure. And that's what we actually have, basically. So on the first step, we have our object ID, partition, transaction ID. So we work with the enroll data, row log, content 0. This is our data. And then we get the data types. So now we know we have 4 columns. And we got our hexadecimal values. And then we actually convert them back. So let's go into the code and check it. So, and actually, I guess we're open to the questions now. Yeah, if anything.
At the moment, we don't have any questions. Everybody's somewhat mind
Okay.
right now.
Yeah, that's cool. So hopefully it's clear. And before we start actually the main script, let's take some, let's say, pre-agreements, some notes. Yeah. It's important to remember that SQL Server stores integer and other numeric data types in a bytes or order. Yeah, I mentioned this, and it's also called little endian because, well, historically it runs on Intel architecture. Yeah, and it has this swapping order on the storage. But SQL Server treats your cast as a direct conversion of int value into binary, so not swapped, and it's actually called big endian. Yeah, so if you want to convert our integer to the binary, so what will be the output? So we actually, yeah, how do we work with binaries? We just put them in the binaries, then to hex for readability. So we have our big endian representation. Yeah, but SQL stores, as I said, in little endian, so it's stored actually in this way. But if we run this SQL, we'll see the representation, big endian, but we should keep in mind that it stores in a little endian, so swapped. So we can also see it here. So yeah, that's why we use this reverse function. And for this, we also have the function get the integer from the next 2 bytes. Remember, I told you on the row structure, we have many things stored in the 2 bytes. That's why I have this one, easily convert them. Well, yeah, we just take some binary, the long one, and starting from the nth byte, we actually convert it, yeah, with the same way. So take as a substring, reverse, and convert to the binary. So here we are. I also have another UDF. This is to get bits from the bytes. And we will use it for interpretation of bit data types, bit columns, because there is some trick with the storage of it. And the thing is, remember I told you about the null bitmap, and it's also stored as a byte. Yeah, imagine this is your null bitmap. So now we see which exactly the columns with nulls. So this is the output, yeah. Pretty simple conversion, but also useful here. So for this, we just create some supportive bit table, and with the values of, well, okay, let me just put something here. So you see, so we just, for our 8 bits, we have the power of 2, and then we have it again because we can have second byte with this bitmap storage, etc. So that's actually it, and we treat the bits, and I just show you it works in this way, and we will use it. Okay, so here we go. Now we're ready to do this exercise. So let's prepare the table. Let's create it. Insert the row. Delete it. Okay, sometimes this happens. I just rerun it. Yeah, let's make sure we have our table name. So I will run it as a SQL script. And yeah, this is pretty fast. You see, we have our database. So let's go inside and see step by step what is happening here. I intentionally put it as a script now for doing step by step, but there is also a store procedure, yeah, with this table name as input parameter, so you can also use it. Yeah, so we have the first block to run. So let's do. And so what do we have here? This is our allocation unit. So we pass the table name, and we see exactly what is our allocation unit, object, and partition. So this is the first useful information we could get here. And in raw data, this is the type of allocation unit. Yeah, meaning we're working with just direct data without loop, without overflow. Yeah, next is the pages. We do store the data in the pages, so we have our place buffer descriptors, so we can take and see what are the pages we use here. So we have IM page, yeah, and data page, what we're interested in here. So we have the page ID. We know there is one row there, and yeah, well, we can output more interesting columns, but I do not need them so far. So just see we have free space on the bytes. Yeah, almost all is empty. Yeah, and page details. So this is the replacement of PDCC page, and there are also nice columns there. I just list some of them here, but for this demonstration, I just use the star to see whatever we can take from there. So now we have our page, and we can pass it just data page. Yeah, that's what we have from the previous one. So we have it here, and there are many interesting stuff here which we'll use. Especially we have page LSN, and that's really cool. Remember, I told you that we have the attributes stored in the header of the data page. So this is one of them, page LSN. So, and that's really helpful. We can pick up it because reading transaction log is quite resource consumptive operation. But yeah, what else do we have here? We have fixed length. This is also something useful for us. So we know the fixed length, this is the total sum of our fixed length columns. And we remember we have just fixed length columns so far. So this is slot count, ghost records, which is basically 0 here because, as I understand, this is heap. And this should be 0 here. And yeah, we can also follow the free bytes. And this is also interesting one. This is actually our transaction ID, which is also connected to transaction log. Yeah, so that's really cool from SQL Server, let's say, creators that they connect these things. So we can use it here. So now let's go to transaction. Yeah, remember we have LSN. And in SQL Server, it's a 96-bit composite structure made of 3 parts. Yeah, VLF, sequence number. So remember, we do store logs in VLF files. Yeah, so first part is our file number. Then we have the block number. So we have block buffer blocks inside the VLF. So this is just the theory. And then we have the slot number. So we have 8 bytes. This is the representation. Yeah, but SQL Server doesn't have a native 96-bit integer because CPUs don't support natively. So that's why it's represented in a varchar 64 string. So this is our second block. Let's work with transaction log. And remember, we have our my page details. Yeah, this is on the screen, on the results. And as I said, we have some links to the transaction. We have this and current LSM. So then we convert it. Yeah, I guess I forgot to mention this one. This is also supportive function. Convert to LSM, yeah, actually to convert representation of varchar back. So we just do the substring and convert it to the ints and cut back. So if we do it here, so we have these representations, yeah, with numbers, and transaction ID, it's just the same as it was on the last column of page details. Why do we actually need this current LSN? As I said, reading the function is very resource consumptive, and as you may know, we have these parameters input, yeah, and this is for the actual LSN. So to start with, so if we pass it, it will be your index seek, yeah, instead of index scan, I would say. That really speed up things. So, and what's the idea? So we know the LSN of the deleted row, so we can start it from there. But the thing is, when I was working on it, I was thinking, okay, maybe we should withdraw not just the deleted row, but the full transaction. So for some investigation, it was quite was quite curious to explore more. Unfortunately, you didn't have much time to do this, but yeah, the idea is to take the previous. We also have the previous LSN stored on the log, so it's double linked, yeah. So we can go forward and backward. And so I thought, okay, let's go and find the last transaction row, which is commit. Let's get it, and then actually take everything related to this transaction from the commit. And one interesting point here, that even commit is your last record in the transaction. The previous LSN of commit is actually the begin run. So it doesn't matter what is inside. Taking the previous LSN of commit, you have your begin run. So it's really useful. You don't have to scan back all the modifications. You can jump directly to the begin with this trick. So with this previous LSN, you have your begin run. So we start with this previous LSN means your begin run. We start with it. And I don't remember if I run this or not. Let's do again. Yeah, so the full transaction. So we found the commit, and you see this is the LSN of commit. It ends with 7, and the previous one, it's 4, and actually that's our begin. So we have the full transaction here. We filtered it by ID just in case. And there are many interesting stuff here. So we can, with this wrappers of commit and begin exec, we can even take more interesting stuff because, yeah, we can see the session, for example, some transaction seed, begin time. Well, anything interesting which is missed for the middle row, which is actually delete. Yeah, but we're interested today in this one to take the rows, take the data from it. Oh, we even have this logs. Yeah. So heap arbitrary and yeah, some description. And this is what we're actually interested in. This is row log content. And these are the binaries. So let's parse them. Yes. Yeah. And yeah, we have our transaction. Remember, we have our caching unit ID, and let's work with in row data. Yeah, we have in row data. So just the row log contents. And we have one slot. What I did here is just row number. Potentially, we could have more rows. Yeah. And just order them based on the page ID and the slot ID. Remember, the slot is the actually your position on the page. So this is the row ID and row log contents. So let's work with this data page. Yeah, so we should keep in mind this structure. So we have bits. That's what I had here. Yeah, just replicate it. And we have 2 bytes for fixed length offset and bytes for fixed length data. Total number of columns. Already mentioned this. Yeah. So then let's run the third block. So covering this stuff. Okay, and here we go. What is actually happening here? The table created to store actually the details, the structure. So let's loop inside the rows. So far we have just one row. Let me, yeah. So we start parsing the rows. So we have fixed length offset, and we remember we have the helpful function to actually pick up next 2 bytes. So we start from the 3rd byte, meaning this is fixed length offset. Then we have the next from after the fixed length offset. From the next one, we have total number of columns. Yeah, because fixed length offset, that means that we're here. Yeah, so we just the offset where the fixed length data ends. So the next one is number of columns. So we start from here and take next 2 bytes. This is here. Then we take, we parse null bitmap size for this row. And then we start, with the var num columns. Again, we start from the calculation for the var num columns. It's here. We know it for sure, so we can precalc in advance and just keep it in the variables. And then let's work with deleted rows. So we have our in-row data. We already have our variables. And there is more things to be parsed without function, but just on the fly. So we have fixed length data. It starts from the 5th byte, because we know for sure the first 4 already occupied. So we start from here. We start reading our fixed length data, and we know where that ends on the offset. Then we have already prepared values, and then we have total null bitmap bytes. This is also calculated based on the variables, and this is for fixed length block. Then we have var length. We do substring, and for based on the number of columns, we calculate offset array, which takes 2 bytes per column, as we remember here. So we have our var offset per each var length column. And that's what we have here. Let's review. We have our fixed length data offset. Remember, we had it on the data page. So this is our fixed length data. We have, now we know we have 4 columns, bitmap. And this is also converted to the bits. So this is quite convenient with this function on the bits. So we now can see the representation. So the 3rd bit is now. So we do not have var columns. So everything is 0 here. And this is just, we do not need it here, as we do not have var length columns. So let's then pivot them with the data types. So we have this undocumented system internal partition columns view. And with it, we can take much more details. So once we join with it, so now we have our offsets. That's important for fixed length data. We know that we have the column names, the data types. We know where we start. We know the length. And some additional stuff that could be useful for numeric, for nullable system types. This is actually the same here. And we calculated, based on the offsets for fixed length columns, we have positive leaf offset, meaning, we just take the max length, we know it in advance. And now let's a bit complicate things and think, what if we have variable length data? This is not our case so far, but that could happen. So actually, there are 3 cases. The first one, we're still with the fixed length, but we have bit column. So for this one, we have to work with the bits. And for this, we have to prepare this bit data. For our example, it's empty. So we come here later for the next example. So we have actually fixed lengths with the non-bit columns. And I would say we're almost ready. So we have pretty much everything. We just need to substring exactly the split it on the columns. So start from the start position and take the column length. And for variable lengths, we'll cover also later. So that's what we have actually here. Remember, we have similar on the slide. Yeah, so we have the hexadecimal value. Let's just analyze the things and convert them based on the data types. We have data types, we have system type ID under the hood, and we're ready to convert. So this is the last block to run. And this is dynamic, so just to represent, it does not insert back, but just for the demo, yeah, we can see the data is back. Yeah, this is the first example. Any questions so far?
Yes, we actually have a couple questions.
Uh-huh.
Adele asks, is this only for delete or can it be done for an update statement which is applied without a where clause by accident?
Wow, very nice one. I hope it should work in the same way, unless it's, well, we're talking about classical storage, yeah? This is not column store where we delete and then sort, we just actually have physical update. So hopefully that will work. Let me note it and try later.
And I'll make sure that you get a list of all the questions. We've been compiling them, so you'll get an email from us. Another question, Thomas asks, since you work your way from the page that stores the LSN and transaction of the last change, what if a second connection modified the data in the table before your script runs?
We're talking about this page details, yeah? Where we store the last, this is the page information. Sorry, this is transaction. We're talking about the page. So we're talking about the page, and it actually stores the last modification, yeah? Whatever is the transaction, who was the last. So let's go, like, directs us to the topic of concurrency and, yeah, the logs and who is the first, who is the second, who have to wait. Well, we shouldn't care. We just know who was the last. We can see them here. So yeah, that's, should I proceed?
We have one more, and this one's related to availability groups. So the question is from NanoDBA. If you have an availability group and you remove the secondary from the availability group after the delete, but before the next transaction log backup, could you then bring that secondary database online and run the scripts and recover the data from that secondary?
So, well, this is about if your transaction is committed, so it's in the log, yeah, it's fully redoable. So that will be on the secondary, and the point was that secondary is off for some reason. Could you?
Okay. And we actually one more came in. Do you want me to ask her? Or do you want to continue?
Okay.
AMS Barry asks, would this be useful for DDL commands such as drop statements?
Drop statements. Well, everything is recoverable from the log, but I haven't explored the drop.
Okay.
Drop, it's DDL actually, yeah. It's could be different stuff, but if you get your row from there, so you can easily parse it.
Okay.
So this is about DMLs. And okay, next one, it's variable. Yeah, let's review this one. So we prepare more columns and one row here, delete. Yeah, there are some bar chart columns here, some bits. Then again, some fixed data, some bits again, nullables, have nulls. So a bit more tricky example. Okay. So in here we are. So I guess we can move to this interesting part with variables. The rest should be the same. So let's start maybe here. So yeah, we have deleted rows. Oh, yeah, we have page details. Again, we have basically the same stuff. We have fixed length. You see it matches. So still one row, 13 columns, fixed length. But now we have 3 var columns and we have the offset 2 bytes each. Yeah, so we can split and take the exact values. So what is here? We have 13 rows. And now we have big data. Yeah, this is also interesting because for the up to 8 bits, they do store in the same byte actually. Yeah, they start from the same start position. You see it's 8. And we also have bits here. So we have also start with 8. Now we should start care about bit positions. So we have 0, 1, 2, 3. This is important to treat them differently inside the same byte. Yeah, that's why actually we prepare this big data, and if it's bit, so get bits from bytes, and all the fixed length data, yeah, we just take it and convert. We have the bits, and then we go to the final representation of before conversion. Yeah, the bit. And yeah, we have bit data. We just substring per bit based on the position. And let's see, well, we'll see what we have. And for variable length, I also prepared some inputs for the of storage. Yeah, for this, I would say not typical data types. And for this max offset, we have power of 215. This is the value. And the max offset stored for, it's possible to have this value. Yeah, but in practice, this is assigned integer. So that's why we have it small int -1. This should be there, but it's signed. So we have this one. And if we start playing with this big data which does not fit the page, yeah, this is the offset. Well, I'm not going to cover this today, but the thing is, we do not store the real value, we store the address of the another position, yeah, the page where we actually store this big data, I would name it. So there are some, we should care about these positions, but in our case, we do not have them. So text and yeah, this is pointer for this reference for the actual data. We do not have it here, so this is could be idea, but potential idea for well, you know, this is not the spaceship script yet, just a bicycle, so we can improve it and add this stuff as well to cover later. But so far we have just var column start position, we have it here, and end position, we also have it. And just by subtract, easily we have the column length. And yeah, let's review. Yeah, we have our chart columns. So, and remember, we first store the fix. Yeah, so var columns go to the end. So the first one starts with position 43, and it takes 150 bytes because I asked it to replicate it this number of times. And then we have next one, exactly the same, and bits. Yeah, now we parse them, and we have again the position, and now we took into account the nullability. So this bit is null. This bit has the value. This one also has, and this one also has the values. Same stuff. And yeah, final data. So here we are, the bits in place, some random varchars, and yeah, this was about variables, variable table. Next one is just bits. So I was playing with it, make sure that, well, I hope it worked properly. Playing with the different combinations of null, zeros, ones, and more than 8 just to cover the second byte. And let's briefly review this one. For the bits, yeah, we have it also here. Row ID, this is the first one. Yeah, the first column null. This is correct. The last one is 1. And yeah, maybe we just check the structure, the bitmaps. Yeah, this is the bit data. And you see, first 8 columns stored. Oops. First 8 columns stores on this, we have set from 0 to 7 positions. On the offset 5. And then from the 9th column, we have, well, this byte is occupied. We start the next one. And this is the continuation of our bits. And as we sort, they're converted properly back. This is just to, and we have nulls, yeah, to parse. Okay, next could be, let's just create dynamic table, prepare some script with the random stuff. So we create some random table with a row. There are some data types prepared. So we create, we insert, we select to have it here, then we delete. So we can also, this is actually universal test for this script. Well, not universal, but more powerful, yeah? So we have the same things back. What I could add about here, I faced some troubles with the date and time data types. Let's go here because we haven't touched this much. Yeah, for the text and char, actually we do not have reverse. So remember I told you about byte swap, but this is not the case for varchar and actually text data. Yeah, just convert back. For integers, we do have a reverse, the proper size. And then we have date and time. So it was a bit problem. So I put it actually here. Date type stores the number of dates since 001, 1st of January, and not this 1900. So to convert the correct date, subtract, we have to subtract this number of days. That's the difference between these bases and 1900s. So we have it subtracted here. And for time, it's stored, as you may know, at 100 millisecond intervals since the midnight. So to convert this to milliseconds, divide, yeah, that's why we have to also parse it correctly. So we divided this. So we have milliseconds now. So we just add them to this midnight. I'm not sure if we have. Okay, if we go to the here we have the DDL memory, date time, tiny int. Well, we have date. Yeah, at least we can check it. So we have 20 February 2020. Hopefully it matches. Yeah, it is. And maybe last example, it's the same. I was thinking, okay, maybe more rows. So let's limit with some small example, 800. So this another script because of additional loop, and this is just random stuff. Okay, we have 700 rows of random stuff. The same table number, table name. So I guess this should also work. Well, here it already started taking some time. Okay, we have some errors. Interesting. Okay, this is our memory stuff. Let's rerun. I would say 700 should take 7 seconds or something. Oh, pretty much it. Yeah, so we have I don't want to compare it row by row, just we can take the first value here, maybe, yeah, just to make sure. And maybe last thing, I also tried to experiment with that was about the heap, yeah. And if we work with the cluster index, there is one additional interesting stuff. So let's create cluster index and well, take the first example. Yeah, it works, but while I was looking on the intermediate temporary tables, it's still the same here. But if we go to the columns, you see we have one additional column, and it's actually on the where part. Yeah. Remember, we have just 4. But this is our, if we start exploring further, this is our unifier, which is added if the index is not unique. Yeah, remember, it internally supports the uniqueness by adding this column. So here it is. So the contradiction here is this system type ID 56 means int. Yeah, remember we have it here. So this is int. So this is integer column, but stored at the where to var length block. Because here actually there is no value. If we go and check the hexadecimal values, okay, it's not here because actually there is no value. Yeah, because there is nothing to be, I would say, deduplicized. Yeah, but if we let's add the second row intentionally with the same. We have column 2 intentionally the same index, and if we run this again, yeah, we have 2 rows, same stuff. Yeah, we have this additional column again, var position. Now you see 4 bytes starts on the 30th position, ends here. And finally, 2 rows. but we can see from the second row, you see we have 4 rows, 4 columns here for the first row. For the second, we have 5. Now this start making the difference. We have this unifier and it has the value, yeah, because it internally has to distinct these values because of the same key. So that's why we have it here, and it's stored on the var length, as I said. Whew. I guess that's all about the demo. So last slide, yeah, I put it. Yeah, maybe a few more things. Yeah, use begin run before you delete. So that's why you can easily roll back. You don't have to dive into these details. Data types matter. Yeah, remember, take the proper one. We can see how could this make the difference. And also remember that truncate is not recoverable. Yeah, it's minimally locked. That's why we know it's fast. It's another question for the candidate on the SQL interview. Yeah, what's the difference? Delete is always locked as a full recovery model. Yeah, all the rows. But for truncate, we just allocate the pages, so we no way to withdraw the data back. Yeah, so I have it on the store procedure. There are some. Well, the topic is not the high tech. This I took the inspiration from the articles and about the row internals and transaction log you can follow. So hopefully this was interesting for at least some people. And yeah, let's stay connected. If you have interesting question just about update, I already appreciate this one. So open to the questions. You can send me and we can discuss further. Maybe some questions for now.
We do have some additional questions. So the first one I'm going to ask just came in from Frank because it relates to the tail end of your demo. They ask, is the extra row the unifier?
It is. Yeah. Even the data type. Or yeah, the data type is int, but it's considered as a unifier for, yeah, as I said, to distinguish the values of the same key.
Okay. Shelly asks, when would this method be more valuable than restoring a point-in-time copy of the database and finding the changes?
Well, I would not say it's super powerful. As you can see, start adding more rows. Well, 700 rows, 10 seconds. So you can work with the dictionary. Of course, this is not for some customer tables. Yeah, with the for dictionaries. Yeah, for 1,000, maybe 10,000. Well, we can maybe play with the numbers. This is a simple solution. Yeah, nice to have in hand. But well, again, of course, if this is production, again, for reading this FNDB log function, you need some additional permissions. Yeah, probably you could not have them on production to run this. This is not just view server state. I guess it's even more. So there are some limitations with it, and yeah, that's the short answer.
Okay, that's fine. And again, I'll make sure you get a list of all these questions so you can revisit them. Couple more. Enzo asks, does this procedure work on a compressed clustered index? And does it work on a clustered column store index?
Well, for column store, I bet it will not work because we have data dictionaries, yeah, where we do store actual data. And well, this one will not for sure, but I guess it's another way to make the bicycle the space rocket, spaceship. Yeah, and add this as additional block to address the column store. I guess the structure of the row will not be the same for sure. For row compressed, I would not be so sure, but again, this is about compression. Yeah, the real data we keep on the page compressed data, and the real data is on the dictionaries. So you should address them. And parse the data from there. So this should be additional block. Yeah, this is a way of improvement of the script.
Okay. Another question, and I apologize if I butcher this person's name. Vesna asks, does this recovery of deleted rows also work on databases with intensive insert and updates? How much time do we have to recover deleted rows in this method?
I think it will work because you have your data page. Yeah, that's important. That's what I highlighted, that we work with exactly the current LSN, which we take from the page information. You know the data page, so you can go exactly on the place of the log where you have it, and you know your transaction ID, so you can filter out just this part which required for your table. So you should not. That's why you just move away. Whatever how much intensive it is, well, you read your FNDB log function precisely this small piece. So that should work because you know transaction, you know the LSN, so you shouldn't care. Unless it's there, yeah, still. If you delete it, I don't know, 1 day ago, maybe it's not already there because of the nature of the log, yeah, wraparound file. So it will be just overwritten in some time. So since it's there, since it's achievable, you can withdraw it.
Okay. Next question. Ozen, again, I apologize if I mispronounce your name. Is this method still applicable after a log backup occurs? Since a log backup truncates the transaction log, what if the database is in simple recovery model?
Well, for simple recovery model, as I said, this matters for inserts, for example, yeah. For deletes, we always have this fully logged. So this is fine. So, and if we just go shall I work on this simple on the database? Yeah, you see it's simple. So that worked. Another one was about transaction log backup. Well, for transaction log, I guess there should be another SQL function similar to FNDB log with a different name, which is possible to take the data from the backups, actually, because this is your recent data here, yeah. With a simple, of course, you with the log, well, okay, short answer, you can just change the function. Actually, I do not have the name in hand. There is a similar one to take from the log backup.
So so you mentioned the log backup. We actually had a question come in just now. And this is from Milliland, is it possible to fetch data from the transaction log backup file itself?
Well, I guess that's the same. Well, I will figure this out and let you know. I'm sure there is a way.
There is also comment in the Slack that's the fn_dump_db log
Cool. Thank you, guys.
function.
So that's it. That's the one. But yeah, we need also to investigate this. You have your LSM that should be there. Transaction also should be there. So I bet it will work.
Okay. Always a good thing for a blog post or to test that out. Enzo also asks, does this procedure work if TDE or transparent data encryption is enabled?
So if it affects the row log, the value, yeah, then if it affects, then that's the difference, yeah, because we take directly what is there without any, we just parse it. So if the encryption changes the value and you need some backward function, so that's one more step to do, but I guess it will be, you'll have the problems there.
We had another question about the backup file, which we've already asked and answered that. Darius had a question: in a busy system where there are many transactions and lots of activity, we have a full transaction log backup every 15 minutes. Am I restricted to the time slice between current and last transaction log dump? I think we've already asked and answered that question.
So you have two functions. You can try the first. If it's still on the tail, use it. If it's already on the backup, use the next one. Yeah, with the dump suffix.
Darius provided more information. I'd like to review my question: how to identify my bad transaction now. Can you clarify that a little bit further, Darius? Please. But I think that was the last question by my count, unless Rob might correct me here in a second.
No, if I unmute myself, I'll tell you that was all that I can see, unless Darius comes back with some more. You've done a great job, John. Vladimir, oh my word.
Oh my gosh, Vladimir, that was incredible.
Oh my word.
That was.
Thank you.
Well, I guess I was quite afraid of such tricky questions because I know so many experts here, and they just another stuff of FNDB function, whatever.
The number of wows we had on our internal chat was a high number. Let's just put it that way.
Yeah. Fantastic talk.
So I hope you can use these guys at least for small tables, and you don't have to bother your admin or whoever. So that's what I learned. So you don't have to pay for third-party tools. Yeah, just apply your knowledge. Maybe that could save your business. Thank you.
Oh, thank you very much, Vladimir. That was absolutely fantastic. We got some fantastic feedback in the Slack channel for your session. We asked for mind melty presentations and demos, and I think we got what we asked for. Thank you so much.
Thanks, colleagues.
Can I grab the screen off you, please?
Could you hold on for 1 second, my friend? Because Darius has
course.
come in at the latest minute for Vladimir.
Oh, well, 100% yes, please. If we have more questions, no worries.
And said, I, as well as many others, issue transactions. I need to go and find my bad transaction. So am I able to go and find my bad transaction in amongst all the great ones that John and Andrew and Anthony have done against the system? I think is the question.
Bad transaction. So what's the question?
The question is, can you identify which transaction I did, as opposed to amongst the transactions that everybody else did?
From the page information, we have it. Luckily, we have it here as the last column. This XPS ID, which is not obvious one. This is your transaction ID. Luckily, so you have it on your page. Yeah. So the data which was deleted from your page, you know the transaction, so you can just take it and go to the log. So that's it.
Thank you, sir. You're a diamond and a gentleman. And Darius said that this was a fantastic demo, and I echo that completely.
Yes, 100%.
Andrew.
Thank you very much, Rob. Vladimir, can I grab the screen, please?
Stop sharing.
Yes, please. Thank you.